So in this video we're going to talk about arc length. So if you remember briefly in our last unit we talked about arc length being parametric equations being the integral from a to b of essentially the square root of f prime of t squared plus g prime of t squared dt. So the length of a space curve is actually going to be defined in a similar way. So definition is going to be arc length of a space curve so we're going to let r of t be the equation defined by the components f of t, g of t, and h of t. And then if we're looking at parametric equations, we can say x equals f of t, y equals g of t, and z is equal to h of t. And then we're also going to look at just the arc between A and B. So letting all these things happen, the length of the curve is defined as follows. So length is equal to the integral from a to b. I'm going to do this a little bit backwards just because I don't want to write the square root and then not have a lot of room to write. So I have f prime of t quantity squared plus g prime of t quantity squared plus h prime of t quantity squared. I'm going to take the square root of that. And of course, cannot forget our dt. If we want to write that in different notation, okay, I have the integral from a to b. I have dx over dt squared plus dy over dt squared plus dz over dt squared. And I would take the square root of that. dt. So that's my definition. We're going to look at one example just because essentially all we're doing is looking at the length of a parametric equation in 3D space. So our example is going to be find the arc length of the circular helix with vector equation r of t is equal to cosine of t I plus sine of t j plus tk from the point 1, 0, 0 to 1, 0, 2 pi. Okay, so the first thing we have to do is they don't actually give us bounds for t. They give us points, but they don't give us bounds for t. So we need to find a value of t that satisfies 1 equals cosine of t, 0 equals sine of t, and 0 equals t. So thankfully, we know that t is equal to 0. So that tells us what t is. So here, this is going to be t is equal to 0. And similarly, for this second one, if I were to start writing it out, cosine of t, 0 equals sine of t, and 2 pi equals t, I would see that t is equal to 2 pi. So 0 gives me the 0.100, 2 pi gives me the 0.102 pi. Okay? So that's the first thing we have to do is figure out our bounds. So now we need to figure out what is r prime of t. So r prime of t is going to be derivative of cosine, which is going to be negative sine. So I have negative sine of t I, and then the derivative of sine, which is cosine. So plus cosine of t j, and the derivative of t, which is just 1, so plus k. So now that I have all of my information, right, so this is f prime of t, g prime of t, and h prime of t, I can plug that into my arc length formula. So it's going to equal the integral from 0 to 2 pi of negative sine squared plus cosine of t squared plus 1 squared. That's all going to be under a square root. Okay. So we're not going to integrate this right away. We're going to simplify it a little bit. Negative sine squared is just negative sine quantity squared is just sine squared plus cosine squared plus 1 squared. So I have the integral from 0 to 2 pi of sine squared of t plus cosine squared of t plus 1. And you may recognize, I forgot a dt, the Pythagorean identity here is going to be 1. So I have the square root of 1 plus 1, which is 2. So really, all my arc length is the integral from 0 to 2 pi of the square root of 2 dt. The antiderivative of constant is just the constant times my variable, which is t, from 0 to 2 pi, which means that's going to be the square root of 2 times 2 pi minus the square root of 2 times 0. Really, that's just me being pedantic. So my arc length is just going to be 2 pi root 2. Okay? That's really all there is to the arc length. The biggest thing is making sure you can find your bounds and your derivative of your function. So in class, we're going to look at that, and I'm also going to show you guys what a helix looks like, a circular helix looks like, because in 3D it's pretty cool. So, less than 10 minutes. Heck yeah.